Today, we are back online, giving you the first of 2 lectures for this week as we are remote for Thanksgiving week. So hopefully you're feeling good. You need to get your packet out in front of you. We are going to go to the page that says Unit 4, History of the Atoms Notes, Part 1. What we need to do in this part of the unit is we need to go through and we need to make sure that we understand how our understanding of the atom has changed over time. We have a very complex understanding of the atom. There is still more that we need to understand. But for right now, we want to make sure that everybody knows how we got to the place that we are. Okay, so we're going to start first about how we try to understand the atom. And that's going to be that we use models. And if I was to ask you, what does a car look like? If you were to describe to somebody what a car is who's never seen a car, what are some things you would say a car has? You would probably say a car has some doors and it has a steering wheel and it has a gas pedal to make it go. And so you could get out a little toy or model car here, got a little Matchbox car, okay, that has wheels that spin, has little doors that open, and it looks like a car. Okay, it rolls like a car. Okay, but this is not a car. But if you were trying to describe to somebody what a car would look like, you could use a little toy car as a model, and that could help you explain something. So a model is an attempt to understand or explain something. Now, you wouldn't need to explain to somebody who's never seen a pen, a model of a pen, because a pen is small. You'd be like, here's a pen. This is what it looks like. However, if you are not in a location where there's a car, you can't easily bring a car in to explain. We have models like things about like the solar system and cells and DNA. And so you will often find that models are used to explain things that are too big or too small to actually work with. So we know that atoms are incredibly, incredibly small. So we use models to try to help explain them and bring them up to bigger so we can see them in real life. So you might have seen things like this is a water molecule. Okay, they're called the little ball and stick models. Okay, you have 1 hydrogen and 2 oxygens. Sometimes we even try to make them seem more realistic, like this oxygen. They say that this water is sticky. Okay, so these will kind of stick together. Again, trying to give you more of the actual ways that water actually acts. So, but the problem is that all models fall short of reality. Just because like our model car that drove like a car and it took gas like a car and it was big like a car and it smelled like a car and it sounded like a car, it would be a car. So as we're talking about our models throughout this unit, it's a big idea to remember that all models fall short of reality because at some point in time, it is just a model. Okay. The other really, really, really big idea that we are going to talk about here is that as we are developing our understanding, all models over time become more complex because we gain more information. Okay. And as you gather more information about something, it becomes more complex. Think about math. When you first learned how to do math, it was very simplistic. You didn't know a lot. And then now as you get into your math career in high school, it is much more complex because you have gained more information. Same thing. When we first were discovering atoms, they were very simplistic. And now they're much more complex because we've made new discoveries and things like that. Okay. All right. So let's go to the first person who is accredited with the idea of atoms. So the first guy you see here, his name is Democritus. So we're going back all the way back to the Greek times. He worked between 370, BC. And what he did was at this point in time, everybody thought that there were only 4 elements, earth, wind, fire, water, and that was it. However, he was kind of taking a look and saying, all right, but if I take earth and then I burn it, that can change something. Or if I eat an apple and then I grow, that's a little bit different. So he kind of didn't think that there were just 4 parts. He actually thought if you could cut pieces of matter down and cut, eventually you would get down to something that you could no longer cut, little pieces that made up all matter. And he named those atomos, which we now call atoms. So he has credit for the first belief of the idea that everything is made of atoms, which is an incredibly amazing feat for just like sitting around and thinking that everything would be made of these teeny, teeny, tiny little atoms. And he had no proof, though. That was his problem. Okay. He had no way. He had no laboratory. He didn't have an electron scanning microscope. He had none of this stuff. And he had someone else up against him. Aristotle is not a part of our history of the atom in discovering anything. He kind of put the damper on it. Aristotle, you've probably heard of him while you have not heard of Democritus. Aristotle is a very important guy. Here he is right here in this very famous picture of the Greeks of your House of Athens by Raphael. He was a very, very smart individual. He's the one in class that always got all the answers right. He did not believe in atoms, okay? He didn't think that Democritus was correct. He was more of the earth, wind, fire, water. Those are the four elements, and then they combine and things like that. So he actually, while he was extremely intelligent, he set us back about 2,000 years. He was not right on this one. So we went along for a very long time thinking that atoms were not real. Okay. Then eventually we ran into some pieces of evidence that would lead us to believe otherwise. So we're going to fast forward all the way up to the 1700s. And the next guy we're going to talk about here, his name is Antoine Lavoisier. And if you can pick up from his name, Lavoisier, he is of French descent. And what he was working on is he was working on the law of conservation of mass. At some point in time, they were talking about when you burn something, you release these chemicals from it, and that's why the mass goes down. But what he ended up doing was he burnt in closed containers, and he found that no matter how much you burned or how little burned, if you could collect it all of the contents stayed the same. So what he was really credited with was the law of conservation of mass. Okay, he is the one that discovered that any chemical reaction he could do, as long as it was in a closed container, the mass would remain the same. And that's something that we do right. We've done this year. The mass before is equal to the mass after any chemical reaction. And what that started having him think was that, well, maybe everything is made of atoms. Okay, started to believe that atoms are existing, because if you have atoms, and let's say you have 5 grams of sulfur dioxide and water, if atoms are real, and they weren't just these kind of 4 magical elements, if you do this chemical reaction and you make H2SO4, it kind of would start to believe that we have all matter is made of these little pieces, like these little puzzle pieces that we kind of just rearrange. So people started to believe that maybe atoms were the way to go, because they're just little puzzle pieces you rearrange, and you can take them apart and make something else, and you can take them apart and make something else. So he was really the first turning point to say, wait a second, Democritus might have been right. Let's take a look at this idea of the atoms. He probably would have made very great strides in his scientific career, except for on the side, he worked as a tax collector for the government. And if you know anything about this time in the French history, as he was obviously getting older, it was not a good time to be a part of the government in France. When they overthrew the government in the French Revolution, because he worked as a tax collector, they actually beheaded him, and his work stopped. But then they found his laboratory, they found all of his work, they found all of the amazing stuff, and they put up a statue of him that you can still see in France. You're like, my bad. Whoopsie doopsies, you were going to make some good discoveries here. So his work was cut short, but it was necessary to get the ball rolling on believing that atoms were going to be true. So then we come a couple years later with this guy named Joseph Proust here. And Proust, at this point in time in Europe, everybody was thinking that whatever they had in their country was the best. And at this point in time, they thought that water in Spain was different than water in England. That was different than water, wherever else. And so everybody thought they had the best water. And so what Proust was doing was he was looking into this, and he would actually split water apart. And you can do this with electrolysis. And what he found was that no matter where the water came from, every time you split it, you got 2 hydrogens and 1 oxygen. And 2 hydrogens and 1 oxygen. It did not matter where that water came from. That water was exactly the same. And so what he wrote was called the law of definite proportions. The law of definite proportions. And what that says is that each chemical compound has a fixed and unchangeable ratio of elements. Okay? So if you have sodium chloride, NaCl, every sodium chloride that's out there, NaCl, is always the same. Salt. Every carbon dioxide molecule that you breathe out has the exact same chemical formula, okay? A fixed and unchangeable ratio of elements. So like I said, his work was with water. It always had 2 hydrogens to every 1 oxygen. And all that did was, again, start to support the idea that maybe atoms exist and maybe everything is made of these little elements that you can rearrange and use. Okay, so he did his work, fantastic. And then the last guy we're going to talk about today, his name is John Dalton. If you've heard any history of the atom, you might have heard of Dalton. He's rather famous. Some people pick up with Dalton because he's the first one that has a model. Now, John Dalton was from a very poor family. He did not have means to a great education. He actually dropped out of school when he was 11 to get a job. He was very bad at holding down a job, but he was very, very intelligent. So when the school teacher passed away in his town at the age of 12, they hired him back as the teacher. So he ended up getting himself a good education because he got into education. Then people found that he was extremely brilliant. He was terrible in the lab, but he was a very good thinker. So what he did, he went to university and things like that, and he put together a theory that pretty much everybody loved. It had taken pieces of information, so he didn't really write any of this fresh. I mean, 2 of them he thought were up himself, but he kind of took other people's work and he made what's called the atomic theory. Dalton's atomic theory has 4 ideas. Okay. The first idea that he came up with is that all matter is composed of atoms, and he gave a little nod to Democritus and kept his word. And the word atomos means indivisible in Greek, so he was using his term there. And all matter is composed of atoms, which are indivisible and indestructible. Okay, so there's a little nod to lovely Democritus. Then the next 2 things were very easy to understand. That's why people kind of latched onto it and thought that was pretty easy. All atoms of the same element are the same. And again, this might seem super simple to you, but somebody had to come up with it first. All atoms of different elements are different. So what that means is that every oxygen atom looks like every other oxygen atom, but an oxygen atom does not look like a carbon atom. They are different from each other. And again, you understand that, but somebody had to say it first. And then the 4th one, he said that compounds are composed of 2 or more different elements in a definite ratio. Okay. So these are his 4 postulates. He put them together, really got the ball rolling on atoms. Now people are starting to believe that atoms exist, going off of these 4 ideas. His theory was so well accepted because the law of conservation of mass is pretty much number 1. Okay, Democritus and then Lavoisier supported and said, hey, we think everything's made of these little pieces and parts that you can rearrange. And then number 4 was simply the law of definite proportions. So he took 2 other people's work and he added 2 clear things into it, and people loved it because it was very, very easy to understand, and it was supported by things that they already knew. So everybody said, hey, Dalton, what do you think these atoms look like? I mean, what must they be? And obviously they didn't have electron scanning microscopes at the time, so he had to come up with the best that he could. And he said, well, an atom must look like a marble, okay? And so his idea, the first kind of idea of the atom, had no pieces or parts. It was simply a marble, okay? Obviously, we know that's different now because we know about protons, neutrons, and electrons. But at this point, we're going to take a stop here for the notes today. And this was our first installment of the history of the atom, how we first thought of it. Then we found little pieces of evidence to suggest that atoms were real. And then good old Dalton put it all together and told us that an atom must look like a marble. Check back tomorrow, and we will continue our journey through the history of the atom. Blessed, never stressed. Got that sunshine on my Sunday bed.